Hello everyone, this is our official Sendo. Today I'm going to introduce a new topics in AI domain interview preparation. Uh, these topics belong to distributed system. Going to talk about how we solve the HackerRank MapReduce problems for word counts. If you like my videos, please support me by subscribing my channel. You can find the complete code for this problem and the order lists are linked to the order videos in description below for coding interview or AI domain interview. So for briefly introduce for MapReduce, it's a framework for processing parallel problems across large dataset using a large number of computers. Processing can occur on data stored either in file system or in database. MapReduce can take advantage of the locality of data processing near the place stored in order to minimize communication overhead. In general, MapReduce framework composed of three operations: map, shuffle, and reduce. I'm not going into details for the definitions. If you want to learn more details, you can check the Wikipedia page for MapReduce. Uh, in later examples, we were talking about how we implement the map, shelf, and reduce. So if the MapReduce is now the popular tool, unfortunately it's not. MapReduce has been developed for a few years, and in software domain, there usually are new toolings to provide more better performance and usabilities. So right now, um, I checked this question in the Stack Overflow. The accepted answer is saying the Sparker right now is faster and easy to work with, and also has more ongoing development than the MapReduce. However, why we still want to learn the MapReduce? Because it's using in tutorials for the basics of the distributed system, and it demonstrates the underlying method by which data is processed in all distributed system. And anyone want to work in big data should understand MapReduce. Okay, so let's dive in the problem. Um, so this problem is word count. It's pretty straightforward in the problem description. So basically, uh, these problems will give us framework for MapReduce and MapReduce executor. So we need to fill in some details in the MapReduce function for this specific problem. So in these problems, we are giving an article by splitting for three paragraphs. I don't snap the full screenshot. Um, however, the first line is belong to one paragraph, and the second line belong to second, and the third and fourth belong to the third paragraph of the article. So then our expected output is to count every words in the articles. What's the frequency of those words appear in the article? For example, the militaries appear once, the words off appear 12 times, uh, etc. So let's look at how we solve this problem. Here I'm using more easy examples. Uh, these articles have two lines divided by line break symbol. The first line is cat, dog, cat. Second line is dog, big, dick. So we want to count the frequency of each word appearance in this article. So here is the MapReduce frameworks provided by the problem. And our job is to fill in the mapper and reducer. So here I already fill for you. Then let's go through these examples for the home framework. So first, main function has been implemented to split the line to read from the standard input. The counter you're using here to count which line it is, but actually it's not used in the future in this example. So I'm just trying to explain the counter here, why it's not used. But actually it doesn't matter for the whole implementation. Then we also pass each line into this framework. Then this framework have an executive function, take a list of line and a factor of mapper and the reducer. Then in the executive function, we have the data. It's a list, so contains each line and the mapper and reducer functor. So first, we iterate all the line data. Then we here is doing some kind of type conversion to convert a string into a kind of dictionary so that we can iterate all the words easily. Then for each line, we run the mapper function. So in mapper function, the key again, we don't use that. It's using like what's the null index here. We are using the value here. The value is, then we split the values. So the cat.cat will be split to cat.cat, right? Then for each words in the split, we update the intermediate value with a word and the value 1. So in the intermediate here, if we basically it's an ordered dictionary, it's a sorted hash map. You can think about it like that. Then it's if it's not key is not exist, so we generate the key and the empty list. Then basically we for each key we append a 1 into the order dict. So what happens is we have cat.cat and we here we generate the cat1, dog1 and cat1 to the intermediate. Then we update intermediate by since here so actually this is so basically we have dog here, so we update dog, append 1 list here. Then for the cat, we have 2 1 in the first iteration, so cat has become 1 and 1, right? So actually in the map function here, we both doing map and shuffle and sort. You also can think shuffle and sort has been implemented in the intermediate. Then for the second line, we also run the mapper. Right now we have dog big dick, like dog big dick, each is given 1 and sent to intermediate. So we update intermediate. We got dog 1, so dog previous has 1 by first line, right? So here we append another 1 into this line, and the big 1. So we generate a new key for big, then append 1 there, and the dig also new key and dig and 1. So after we iterate all the line, and we call 2 times for the mapper. So basically we done the map and shuffle and sort steps, which is the traditional schema for the MapReduce framework. So next, for each key in the intermediate, we implement the reducer. So what reducer does is take a key and a list of values. For example, for cat, this is the 1 is the list of values. Is count the total of them and emit for key and total. The emit here is really simple. We just append a pair for the key and its count into a result list. So for examples, the key is big and its list is 1. So we basically count its frequency for the big and append to the result. For the cat, we have 2 value here, so the total will be 2. So we append the cat 2. Dig is also 1 and dog is 2. So then we done the reduce phase here. Eventually, for each items in the result, we just output. So by looking for the whole schema, we can observe that this few plays can be run in parallelly in different machine, right? For example, the split here, and we do the split means like we get a whole paragraph and split into the several part. Here we are splitting based on each line based on the line break. Then we can also do the map in parallel, since it's just generate a pair for each key and the one. So in shuffle and sort, this part maybe have some constraint for parallel computing. Also, think about that if we have too many keys, the shuffle and sort here may take a lot of time. So this may be a bottleneck for MapReduce to be optimized. So there may be some tricks to optimize this. Then for the reduce, since we have those lists for each separate keys, right? So to count how many members for each keys is also a parallel programming. Then we aggregate all those results into a list to output. So okay, so all the things I want to talk about in these videos. Hopefully you like this topic. Please leave your comment and suggestion. I'll see you in next video.